Hi again, everybody. We are continuing on with the 6-1, 6-2, 6-8 review. And we are going to move on to evaluating expressions between 0 and 2 pi. So again, in the last unit, we talked about, we did problems like this where we were given a ratio and we had to figure out what quadrants those ratios were in, depending on what the trig function was, and then what the reference angle was. And then once you had the reference angle, what the one or two angles were at those two spots, one or two spots. But we gave our answers in degrees. So the difference now is we're giving our answer in radians. Okay, so I'm going to start with 17. So remember, we talked about where these trig functions are positive. So we did all students take calculus. So for 17, I'm talking about cosine. Well, I know that cosine is positive in the first and the fourth quadrant. So that means cosine has to be negative because that's a negative fraction in the second and third quadrant. So that's where I'm going to draw my two triangles. Okay, because it's a negative ratio. And then I'm going to think, okay, cosine is A over H. So from the center, I'm going to label my opposite. Well, I don't know what my opposite is yet, but I know my adjacent is square root of 3. I'm not going to worry about where the negative is yet. And the hypotenuse is 2. With the bottom triangle, the adjacent is square root of 3. The hypotenuse is 2. So it was actually negative 3 there. In a way, we don't care because really what we want to know is what is opposite the angle. And this is a 1 square root of 3, 2 triangle in both cases. And the angle across from that has to be 30. And I'm just going to leave it 30 for now. So if we're thinking in terms of radians, that is the same as pi over 6. Okay, so 30 is the same as pi over 6. So the reference angle here is pi over 6. The reference angle here is pi over 6. So we want to know what this angle is here, starting at 0, and how far it is all the way around to here. So basically, there's two ways we can think of it. We can either think, okay, that's 150 and then convert it into radians. But the other thing I can do is I can realize, well, if this is pi here, which is the same as 6 pi over 6, and I have a reference angle of 30 degrees, which is the same as pi over 6, probably easier to do the bottom one first because I'm going half a circle, which is 6 over 6. I add another 1 over 6, and I end up at 7 over 6 pi. If I'm thinking about this one here, let me just redraw this. It's 6 over 6 minus 1 over 6, which is 5 over 6. There, redraw that. 5 pi over 6. Okay, so those are the two solutions there. Where is the cosine equal to negative square root of 3 over 2? It occurs at both 5 pi over 6 and 7 pi over 6, which is equivalent to 150 degrees and 210 degrees. Okay, let's try another one. So number 19. When the tan is 1, this is always tricky because usually when we're looking for the inverse and we're given a ratio of 1 or 0, which is 0 over 1, 1 over 1. We think that that is on the x-axis or y-axis. But the one exception is when we have the tan is equal to 1 or negative 1. So I still want to go back to this all students take calculus and think, okay, if this is where everything is positive, where would the tan be positive? Because this is a positive 1. Well, it's positive in the first quadrant and the third quadrant. So I will draw it here and here. Okay? And just a reminder, this is 0, this is pi, this is 3 pi over 2, pi over 2. Okay, so that's where the tan is. Now remember, tan is opposite over adjacent. So I need a number for the opposite, I need a number for the adjacent. Well, 1 is the same as 1 over 1. So my opposite is 1, my adjacent is 1. So from the center, my opposite is 1, my adjacent is 1. Here, my opposite is 1, my adjacent is 1. Technically, those are negative, don't really care, because we're looking for the angle. So, you know, what kind of a triangle do we have? A 1 and a 1? It's square root of 2, which is the same as a 45-degree reference angle in both cases. Now, 45 degrees is the same as pi over 4. I'm going to move this a little bit. Nope, I guess I'm not. Maybe I'll erase it. Okay, so this reference angle is the same as pi over 4. So if we start at 0, this is 0, and we go to up here, where do we end up with? Well, 0 plus pi over 4 is pi over 4. If I'm trying to get to this point here, I'm adding pi plus pi over 4. Now remember that pi is the same as 4 pi over 4. So 4 over 4 plus 1 over 4 is 5 over 4. Okay, so those are the two solutions there. Okay, let's look at 21. It's to be kind of a mess here. There's not a whole lot of room. We still have tan again. This time it's a negative. Again, it's not a ratio. I want to make it a ratio by putting it over 1. So I'm not going to worry about the negative. Tan is O over A. And where is the tan negative? So kind of going back up here again, the tan was positive in the first and third. So tan is going to be negative in the second and the fourth. From the center, my opposite is square root of 3. My adjacent is 1. This is a 1 square root of 3, 2 triangle. Same here. Opposite is square root of 3. And again, I could, you know, add my negatives. Don't really care. But now if I think, what is normally across square root of 3? And it's either 30, 60, or 45. On that same token, that's the same as 30 is pi over 6, 60 is pi over 3, and if it's 45, it's pi over 4. So 60 degrees is really what we have. That's the same as pi over 3. This is pi over 3. So remember, this is 0. This is pi. You know what? I'm going to remember this is pi over 3 here. So I'm just going to make this 3 over 3. Over here, I'll make this 6 pi over 3. Because then if I'm trying to think, okay, where am I at if I go all the way around? Well, it didn't go all the way to 3 pi over 3. It fell short of that. So I'm going to go 3 over 3 minus 1 over 3. So I'm taking this minus this, because 3 over 3, I'm backing up pi over 3. I end up at 2 pi over 3. So it's just like we took 180 minus 60 is 120. But here we went 3 pi over 3 minus 1 pi over 3 is 2 pi over 3. And finally for this one, again, you know, if I want to, I can go, okay, 3 pi plus 2/3. But it's probably just as easy to go, okay, 6/3. I'm going to back up 1/3. 6/3 minus 1/3 is 5/3. So our two solutions are 2 pi over 3 and 5 pi over 3. Let's move on to 22, because this again is a 1, but remember most of the time when we get 1 and 0, it's on the line. The only exception is when the tan is 1. So this is one where it's going to be on the line. This would also, 27 arc cosecant. Cosecant is related to sine, so that would also be 1 there. Okay, so I'm going to think, okay, this is 1, 0, 0, 1, negative 1, 0, 0, negative 1. And when it's on the line, we have to think that cosine is first, sine is second. And we're talking about where is the cosine equal to negative 1. So where is that first number equal to negative 1? Well, not here, not here, here though. The cosine is equal to negative 1. That is at 180 degrees, but of course we want to think about radians. So it happened at pi. Only one spot, pi. Or again, same as 180 degrees, but we're doing radians now. Okay, let's do 25. We're just going to do a couple more of these, then we'll look at the back page. So 25 cotangent. So cotangent instead of OA is AO. Again, this is positive. It's a positive fraction. So where is tan positive? In the first and the third. And if that's the case, that's where the cotangent is also positive. So my opposite is square root of 3. My adjacent is 1. So really, I don't even care about the negatives. I really just care about what is across from square root of 3. Well, it's the same as 60 degrees. 60 degrees is the same as pi over 3. Pi over 3. And again, if this is 0 and this is pi, okay, at least this time we don't have to go backwards. So if I start at 0, how do I end up here? I go 0 plus pi over 3. So that angle is pi over 3. How do I get all the way around here? Well, 3 over 3 pi plus 1 over 3 pi is 4 over 3 pi. Okay, and one last one, and this is where is the cosecant equal to 1. And of course, 1 is the same as 1 over 1. But again, cosecant is related to sine. Anytime we see a 0 or a 1, we're thinking on the x-axis, y-axis. Only exception is, the only exception is the tangent. So this is 1, 0, 0, 1. This is negative 1, 0. This is 0, negative 1. But remember, the cosecant is really 1 over the sine. So if I want 1 over the sine to be equal to 1, my sine has to be 1. I want to know where is the sine equal to positive 1, because that's the only thing that's going to give me a cosecant equal to 1. Cosecant is just the reciprocal of sine. So the only spot where the sine is equal to 1, remember it's cosine sine, cosine sine. Not here, not here. The only spot was right here, which was at, same with as 90 degrees, but 90 degrees is halfway to pi. It is at pi over 2. Okay? All right, I'm gonna stop this video and we'll make one last video of the final page of the review.